Hey, welcome back. In the last video, we learned a few uProperty specifiers that allow us to expose our C++ variables in certain ways to the details panel in the blueprints. In this video, we're going to learn some more specifiers that allow us to have more control over access to those variables in the details panel. We're also going to talk about how we can allow read or write access in the actual event graph for a particular C++ variable. So let's dive right in. Okay, so I'm back here in VS Code, and here are the variables we created in the last video. Now here is my speed variable. This was for the challenge. You probably created a different variable, which is totally fine. So keep that variable there. We're going to do some more things with it in this video. Now we've learned that we can make a variable visible anywhere. And when we say anywhere, we mean on the details panel, either on an instance or on the default blueprint. We saw that we can also make it edit anywhere. And when we use visible instance only, it's only visible on an instance. You can't even see it on the default blueprint, and in any case, you can't edit it because it's grayed out. So this allows us to make our variable visible only on the instance, but what if we'd like it to be visible only on the default blueprint? Well, there's a specifier for that too. Let's make another int32, and let's call this visible defaults only int, and we can initialize this to a value. I'm going to give it 5. And we'll give this a uProperty as well. And the specifier for making this visible only on the defaults, you could probably guess what it is. It's visible defaults only. So I'm going to compile this. And back here in the editor, I'm going to open up bppontank again. And with bppontank self-selected, all of our variables are up here at the top, so I'm not going to search for it. But here's our visible defaults only int, and it's got the value 5, and of course it's grayed out. Now, as the name suggests, it's visible only on the default. So if I go in the world and select one of the instances of bppontank here, there is no visible defaults only int. It's not visible on the instance, only on the default. So that makes sense, right? Now let's go back into VS Code, and we have a few more specifiers to learn about. Now we've seen that we can edit anywhere, and that with our visible specifiers, we can choose instance only or defaults only. So as you've probably guessed, we can edit on only the instance or only the defaults if we choose. So let's make a couple more int32s. I'm going to make one called edit defaults only int and initialize that to a value, say 9, and then another int 32 called edit instance only int. And I'll give this a value of 14. So we want edit defaults only int to be editable only on the defaults, and edit instance only int to be editable only on the instance. Now, the names of these specifiers are pretty consistent, so I'd like you to just guess what the specifiers would be for these two access levels. Go ahead and just do a quick little mini challenge, pause the video, and fill these in, see if you're right. Okay, so these are going to be uProperties, and edit defaults only int is going to get, you probably guessed it, edit defaults only. And for edit instance only int, I'll give this a uProperty, macro, and this will be edit instance only. So it's pretty intuitive. Let's go ahead and compile these. And back here in the editor with bppontank open, here's our edit defaults only int. We don't see edit instance only int. We didn't expect to. It's set to 9 here. We can change it. And if we go into the world with one of our instances selected, we can see edit instance only int. And of course, that's editable as well. So we've now added 3 new specifiers to our graph here. We have visible defaults only, which is in only the defaults column and in the read-only row. And then we have edit defaults only and edit instance only in their respective rows. So we're filling up this graph pretty quickly, but you'll notice that there are a couple of spaces empty over there to the right in the event graph column. So let's talk about these for a minute. Now I'm here in bppontank. And we have all of these variables that we've exposed to the details panels. Depending on their specifier, you can see them here or on an instance. But what if I right-click here in the event graph? The event graph is another place where we can access variables and potentially change them. So if I type edit anywhere, I do not see the edit anywhere int. It's not exposed to the event graph. We don't have access to that. There is another specifier that allows us to expose things here in the event graph, and that can work in conjunction with the specifiers that control the details panel accessibility. So I'm hopping back here into the editor, and I'd like to expose one of these variables to the event graph. Now, I could choose any one of these, but I'm going to choose this visible anywhere int. Now, the uProperty macro can take multiple inputs. So we have visible anywhere. We can still have that. I'm going to place a comma, and I'd like to add another specifier that will give this visible anywhere int exposure to the event graph. So what I'm going to use is blueprint read write. Blueprint read write has to do with the event graph. It has nothing to do with control over the details panel. That's what this visible anywhere is for. So blueprint read write does as the name suggests, read access and write access. So let's see how that looks. Let's compile this. And I'm back here in the editor. In the event graph, if I right click and type visible anywhere, we'll see two different options: get visible anywhere int and set visible anywhere int. If you select Get Visible Anywhere int, we get a node, and this is just like any other Blueprint node. It represents that C++ variable. And if we drag off of this, we can access that value to do something with it. Now, I'm going to scroll out, and you'll see that we have these grayed out nodes, actor begin overlap and event tick. There's usually a begin play here. Now, these are grayed out if they're not used. So you can drag a wire off and do some Blueprint logic, and then it won't be grayed out anymore. Now, since I'm not seeing my begin play, I can always get that by right-clicking and typing begin play. So there's my event begin play node. And begin play is called at the beginning of the game, as you know, so we can do something here. I'd like to use a print string node, and if I drag off and type print string, then here it is. It's a Blueprint function node, and it takes a input called inString. Now, if I hover over it, it says inString and then string right below that. That's the type that this node accepts as an input parameter. And we know that our visible anywhere int is an int32, not a string. But if you click from the output of this node and drag and stick it right here in the input, before you release the left mouse button, you see a pop-up that says convert integer to string. And if you release, then you get this handy conversion node that converts from an integer to the string type, which is very handy for us because we don't have to figure out how to convert an integer to a string. It's just automatic for us. Now, if I hit play, we'll see the value 12 printed 3 times, and it only lasts for a few seconds. That's the behavior of print string. Now, the reason we see it 3 times is because I have 3 different instances of bppontank here in the world. Depending on how many you've dragged into the world, you'll see that many, because for each of these individual instances, begin play is getting called at the beginning of the game. So just to avoid confusion, I'm going to just delete my other 2 and just leave a single instance of bppontank here in the world. So I have only 1, and if I go and hit play again, then I see 12 printed to the screen only once. So that is read access to visible anywhere int. But we saw that we also have write access. That means we can set its value from here in the event graph. So if I right click and type visible anywhere int again, then I can select set visible anywhere int, and I have a setter node, which takes an input. We can pass in the value from some other node, or we can take this little text box and hard code a value, say 66. And now as soon as the flow of execution from begin play reaches this node, then the setter node is going to write to visible anywhere int. It's going to set its value to 66. And of course, we can print this out again. So I'm going to use print string. And for the value passed into print string, I'd like the value of visible anywhere int. Now I can do this one of 2 ways. The setter has a return node. So after it's set the value, then it returns that value and we can use it. So we can plug it straight in to print string. The other way is to simply right click and get visible anywhere int, use that get node, and we can hook up the value from this node right into print string. That would do the exact same thing. So I don't need that. I'm going to delete that node. And now what I'm expecting to see when I play the game is to first print out the value of visible anywhere int, which starts off at 12. And then after setting its value to 66, I should see the value 66 printed out to the screen. So let's hit play and we see 12 and 66. Now they look like they're in reversed order. That's because print string adds newer messages on top. So that is normal behavior. Okay, great. So we've seen that we can make a variable blueprint read write. Now we can also control whether or not we can set this from the event graph. So let's expose another variable so that we can get it from blueprints but not set it. Here's edit anywhere int. I'm going to add a comma and add a specifier to this. Now, in order to access it in the event graph but not be able to set it or write to it, the specifier is blueprint read only. So edit anywhere int is now blueprint read only. It's still editable in the details panel, both in the default and on instances, but in the event graph, it's read only. So let's go ahead and compile this. And back here in the editor, I'm going to right click in the event graph and type edit anywhere. And check it out. We have get edit anywhere int, but we do not have a set edit anywhere int because it's blueprint read only. We cannot write to it. So I'm going to select it. Here's edit anywhere int. And if I wanted to, I could use a print string node to see its value. No need to do that. We already know how to do that. I'm just demonstrating that we cannot write to this variable. Okay, so I'm going to go ahead and highlight these nodes and delete them. So our graph is now filled out. We've learned that we can make our variables visible only on the defaults, and we can make them editable only on the defaults or only on the instance. So we really have full control from the C++ side. Now we also saw that we can expose these variables to the event graph and make them read-only or read-write using these blueprint read-only, blueprint read-write specifiers. So now you have a challenge. In the last lecture, we created a variable. I made a float and called it speed. Now, you're going to take that variable you created in the last section and control its access in the event graph. So expose it to the event graph using one of the new specifiers you've learned. And then you're going to test out the read-write access for this. Use a print string node so that you can see its value, and if you change it, prove to yourself that you've changed it. So if you make your variable blueprint read write, try changing it with a set node and then using a print string node to see its value using event begin play. If you made it blueprint read only, then you can simply get the value and print its value using print string. So add the correct specifier to your custom variable and use print string to test out access in the event graph. Pause the video and give this a try. Okay, so I'm going to scroll down to my speed variable here, and my speed variable is edit anywhere, and I'd like it to be blueprint read write so I can change it from within the event graph. So I'm going to add blueprint read write and simply compile. And back here in the event graph, I'm going to right click and type speed. Now the variable I created is not showing up here, so I'm going to go ahead and close out of the editor, save everything, and open up my project once again, just to make sure everything has updated. This is something that you may have to do if you're not seeing the results of your C++ code. So back in bppon tank, if I type speed, now I see the getter and setter for this. So I'm going to use set speed. I'm going to set its value from begin play. So let's hook this up. And for the value, I'm going to enter 900. And from the set node, if I drag off, I can type print string. Now I'm going to click and drag off of the output node, hook it up to string, and notice mine says convert float to string. That's because my speed variable is of type float. So if I hit play, there's 900. Notice it says 900.0. That's because this is a float, and so it's giving me the courtesy of showing that first decimal point. So that's kind of a nice built-in feature here. It's showing me one digit to the right of the decimal point for my speed variable. So in summary, we learned some more specifiers for the uProperty macro. We learned visible defaults only, edit defaults only, and edit instance only. And we also learned how we can control read-write access in the event graph with blueprint read-write and blueprint read only. The C++ programmer has a great deal of control over what gets exposed and what can be changed in the blueprint and where. We'll be using these throughout this section of the course, and you'll continue to use them throughout your career as an Unreal Engine developer. I'll see you in the next lecture.